Let's see if people still like pixel art. Hi coders, welcome to another episode of my game development series where we learn how to build games from scratch with no libraries, using just plain vanilla JavaScript and HTML canvas. I built another game prototype just for this tutorial. You can see we have our main character. I picked Chewbacca, but we will have plenty of Star Wars sprites available to choose from in case you want to play as someone else. The game will be set on the desert planet of Tatooine, which orbits 2 suns. We have waves of random Empire characters and Dark Side of the Force users coming from the right. And we have Republic refugees being escorted by Jedi forces to the rescue ship. If you are a Star Wars fan, you will recognize Millennium Falcon. Player character will have to intercept enemies before they reach refugees. There is a simple collision detection algorithm between player and enemies, and between enemies and refugees. We have score count, so in this game we will eat Empire and Sith forces, and we will keep track of how many we have eaten. We will also keep track of how many refugees we have saved by allowing them safe passage to the rescue ship, and how many refugees we have lost by allowing them to collide with invading Empire. I implemented simple AI. If the player character doesn't move, most enemies will avoid it and try to walk around it, so there is some automation. I guess this game could be used as a screensaver or maybe interactive website background or something. There's a lot of movement going on even without any player interaction. I use random dust image that quickly flashes when we have collision. It could have been more animated, we might do that later. In today's tutorial, we will practice JavaScript techniques that are useful for web development in general, not just for games. We are front-end web developers, and these exercises are here to help us to improve our skill set and learn new things. We will focus on event listeners, array manipulation, and pulling and handling data stored in an object, and while doing that, we will learn how to create a player character and move it around canvas with keyboard. In the previous episode, I just placed the background image in our game using CSS. This time, we will do it properly and draw game background on canvas. Since we are using simple pixel art sprites, we want to be able to set custom FPS to request animation frame method. By default, the animation will be extremely fast on most modern computers, and characters will be zooming across the screen, and especially sprites will be animating way too fast. There is a way to throttle sprite animation with algorithm. We could also simply slow down our game by using custom set interval instead of using request animation frame. But let's do it the proper way and employ the best practices. I will show you an algorithm using Data.now JavaScript method that will allow us to set FPS in our game in milliseconds. This will be consistent across all machines regardless of how strong user's computer is. I had so much fun building this one. You can click the like if you want more game development tutorials like this one. It helps me a lot. Let's start coding. In index.html, I link style CSS file, script.js file, and I create HTML5 canvas element with an ID of canvas1. In style CSS, I set canvas width to 800 pixels, height 500 pixels, border 1 pixel solid black, background will be a nice desert sand color, and we center it in the middle of the screen by using absolute positioning trick, position absolute, top 50%, left 50%, transform translate -50%, -50%. Everything else will be done with plain vanilla JavaScript in script.js file. I use getElementById to target canvas element and save it in a variable I call canvas. CTX will be canvas.getContext2D. This will give us access to built-in canvas methods. Canvas width 800, canvas height 500. I create constant variable I call keys, and for now I set it to an empty array. We will use this array to keep track of what keys user pressed on keyboard using key up and key down event listeners. I will explain in a minute. I create another variable called player, and I set it equal to JavaScript object, and I will give it some properties. We will use this object to store all data about our player character. X will be player's current horizontal position on the x-axis, Y will be vertical position on the y-axis. Width of the player will have to be calculated based on what sprite sheet we choose to use today. Same for height. Let's finish building the player object and get back to this. Frame X will be horizontal coordinate of frame we cut out from our sprite sheet. Frame Y will be vertical coordinate. We already did this and I explained in detail in previous videos. Sprite sheet is an image that consists of several smaller images, so-called sprites, combined into one larger file. We show only one frame at a time by cropping out and showing only a small portion of that image. Frame X and frame Y will store coordinates of a rectangle we want to crop from our sprite sheet when we are animating our player character to show only one frame. Speed will determine how many pixels we move per frame of animation. Let's try 9. And moving will be set to false. We will use this value to switch between standing and walking animation a bit later. So how do we calculate width and height of our player character? We've done that in the previous tutorial. First, we need to get a sprite sheet. Player sprite will be new image, which will create an instance of built-in image object. And I set its src value to the path to our sprite sheet. I have discovered an amazing website, link in the video description. Do you like pixel art? Because I do. Apparently this guy loves making sprite sheet. He has built so many, look at that. International costumes, pirates, ooh, steampunk, elves, wedding. Is this some Japanese anime? He also made Marvel Cinematic Universe set. Wow. We have Hulk here. Drax from Guardians of Galaxy. I will make another game with these for sure. We also have Indiana Jones. Disney. Is this Aladdin? Yes, it is. Sweeney Todd. Good Omens. Discworld. Wicked. And a huge collection of Star Wars sprites. Amazing. Must have been so much work. There's also anime and games section. Oh, Final Fantasy. I will be playing with these sprites for a long time after I finish this video. Let's check out what Star Wars sprites are available. What is this? Twi'lek Jedi? We have Mandalorian, Stormtrooper, Darth Maul, Yoda with a cane. This must be Darth Vader. Chewbacca. This will be our main player character today. Let's grab the sprite sheet. You can see I have two images here. Background I drew in Photoshop and Chewy sprite sheet. So I set player sprite src to chewy.png. For you the path might be slightly different depending on how you organize your project folder. We need to calculate player width and height. Our sprite sheet is 160 pixels wide and we have 4 columns. 160 divided by 4 is 40. Player width is 40. Sprite sheet height is 288 pixels and we have 4 rows. 288 divided by 4 is 72. Player height is 72. In the previous video, I just placed background image using CSS. This time, we will actually draw our background using JavaScript and Canvas. Const background is equal to new image. To create instance of image object and set its src to background.png. I drew this myself in Photoshop. You can download that image in video description. Now I create animation loop as we always do. Custom function animate. You can call it whatever you want. First I call ctx draw image This built-in canvas method has 3 versions as we discussed in previous video. We will use the short version that takes only 5 arguments. The first argument is what image we wanted to draw, so background as I declared it on line 21. The second and the third arguments are coordinates of top left corner to start drawing from, so 0, 0, and the last 2 arguments are width and height of the area we want our image to fit into, so let's make it cover the entire canvas by saying canvas.width and canvas.height. Now we call it on the top level, so animate, with brackets, and also we call request animation frame and pass it animate, the name of its parent function. This way our custom animate function will run its code and then request animation frame will just run it again and again, creating our animation loop. Star Wars fans will recognize this ship as Millennium Falcon, and desert planet with 2 sounds is of course Tatooine. Do you like my Photoshop drawing skills? As I said, the second and the third argument stand for position X and position Y, from which we will start drawing on canvas. So if I change these values, the image will move like this. We have our base structure working. Just to show you that animation loop is running and drawing background image over and over again, I can do something like this. I create a variable called position and I set it to 0. Now I replace position on the x-axis with variable I just created, and for every frame of animation I increase that number by 1. Now I can also see that all the images we drew are staying on canvas. Let's call ctx clear rectangle method to clear entire canvas between every animation frame. Like this. Okay, let's just delete these. We want a static background. It's time to draw our character. Since we are using Sprite sheet that contains multiple images, we will have to use the longest version of draw image canvas method. We need to tell JavaScript not only what image we wanted to draw and where on canvas we want to draw it, like we did with background, we also want to tell it what area from Sprite sheet to crop out to show only a particular frame. I could call draw image directly, but to make this a bit more reusable and flexible for future added features, I will create a custom function I call draw sprite, which will expect 9 attributes. And inside, we just call built-in draw image canvas method and pass it the same attributes. I will explain what all these mean in a minute. The advantage of wrapping all of this in custom draw sprite function is that it allows us to pass additional custom arguments and do something with these values. We will not do that today, it's just to explain why I wrap it like this. So we have the longest version of built-in draw image canvas method. Its job is to take image we pass it as the first argument, cut out portion of that image, so in case of Sprite sheet, to only show 1 frame, and place that cut out image somewhere on canvas. That's why it needs 9 attributes to be able to do all of that. This method is fundamental for drawing sprites with JavaScript. We have gone through it in detail in the previous episode, so let's just quickly explain it again so everyone knows what's happening. I go inside our animation loop, and here I call drawSprite custom function. The first argument is the image we want to draw, so player sprite. The next 4 arguments are 4 coordinates of area we want to crop from the sprite sheet to only show 1 frame, so source X, source Y, source width and source height. It crops image from top left corner going down and right. Source X will be 0, source Y will be 0 as well. That's top left corner of our sprite sheet image. Source width is player width and source height is player height. We want to crop a rectangle that's the size of 1 player frame, as we calculated on lines 12 and 13. The last 4 arguments determine where on the destination canvas we want to draw our image, so destination X, destination Y, destination width, and destination height. Let's draw it at first in a corner, coordinates 0, 0. Size will be player height and player width, so it's the same size as original. If you say player width times 2 here, you can also scale your sprite like that. Something's wrong, let's see. Yes, drawSprite is our custom function, so I need to remove ctx here. And Chewbacca is squished for some reason. Oh, it's because I swapped width and height here. First width, then height. There we go. Let's change destination X and destination Y values to draw it at different coordinates. Like this. Well done, you managed to draw background and one frame from character sprite sheet on canvas using nothing but plain vanilla JavaScript. Now we can animate our character by changing values inside our custom player object we created in the beginning. I create an event listener for keyDown event with callback function with E that stands for built-in event object passed as an attribute. I also make one for keyUp event. And I need to learn the correct syntax for add event listener. Now it's fixed. We will keep track of what keys user pressed on keyboard by adding and removing values from keys array we declared in the beginning on the line 6. Let's look at the code on line 36. We have event listener on window object. It takes two attributes. The first one is what type of event we listen to, in this case keyDown. The second attribute is a callback function that will run whatever code we put in it whenever keyDown event occurs. Callback function of event listener has by default access to a built-in event object. Here you can see me pass it as the letter E, but you can call it whatever you want. Some people call it event. JavaScript will know what you mean because attribute passed to callback on event listener is always referring to event object. Event object contains a lot of information about that particular event, depending on what type of event we are listening for. It can contain X and Y mouse coordinates, and in this case E.keyCode will refer to a key that was pressed on user's keyboard. You can display all information contained within the event object by calling console.log E inside the listener. Every key on keyboard has its own keycode. You can check which is which by running console.log E.keyCode and pressing random keyboard buttons. It will give you the numbers in browser console. Just a side note, I read a couple of articles after recording this and it's not recommended to use E.keyCode anymore. We should use E.key next time. Now I'm gonna do something that might look strange to you. I take keys array we declared on line 6 and in brackets I pass it E.keyCode and I set it to true. It's just another way to add element into an array. Basically, whenever key is pressed, we add that key into our keys array. That's all that's happening here. On keyUp event, I will call special keyword delete and delete that key on which the keyUp event occurred from our keys array. Don't overthink this, it's very simple. When we press button, we add that button's keycode into keys array. When we release that button and keyUp event occurs, we remove that button from keys array. You might think it's unnecessary to use array for this. There is obvious simple solution, but if you just change X and Y values of our character inside these event listeners, you will notice that when you play a game and holding down right arrow, for example, to walk right, you actually press left arrow before you release the right arrow if you want to walk left. This means that keyUp and keyDown event will fire over each other and your character will not be moving as you are used to in video games. I really like this solution of keeping track of pressed keys in an array, although I will show you another way to do this in the future. I put console.log in keyDown event and I log our keys array. And you can see that it adds and removes values as I press my keyboard. So now, currently pressed key is added to keys array on keyDown and removed from the array on keyUp. On line 31, if I change the sixth attribute we pass to our custom drawSprite function, it changes where the character is drawn on the canvas along the horizontal x-axis. So I replace this value with x value stored in our player object, player.x, and I do the same for vertical y-axis, player.y. Now we can move our character by changing player.x and player.y value like this. Let's create a custom function. I will name it, for example, movePlayer. It will contain if statement. As I said, our keys array adds currently pressed keyboard key on key down and removes it from the array on key up. So here I just simply say if keys 38 is true. 38 is key code for up arrow on keyboard, player y minus equals player speed, which will move our character in the negative direction along the vertical y-axis. So if I now call movePlayer from animation loop, player moves up. I don't want the player to be able to leave screen completely. Based on the background we used here, I want it to be able to walk up only to the level of the spaceship. So let's add additional condition. If keys 38 is true, meaning if up arrow key was pressed on the keyboard and added to keys array, and at the same time, if player Y position is more than 100 pixels from the top, only then move player up. Also, if I look at the sprite sheet, on line 14 inside player object we declared property called frame Y, which determines vertical coordinate of the frame we crop from the sprite sheet. So basically it determines which row we are animating. On this particular sprite sheet you can see that the bottom row is walking up animation. We crop from the top left corner, so we count rows from 0, 0, 1, 2, 3. On line 31 in drawSprite function we already said that second, third, fourth and fifth attribute we pass determine area of one frame we crop from the sprite sheet. So as the second attribute I pass player width times player.frameX. So if player frame X is 0, it will crop from 0. If it's 1, cropping area will skip one frame, player width times 1, and start cropping from where the second frame starts. That's all just for horizontal x-axis. We do the same for the third attribute, so player height times player frame Y for the vertical axis. So again, the first attribute we pass to drawImage canvas method on line 25 is the image we wanted to draw. The next four attributes determine rectangular area which we want to crop from the sprite sheet, so we only display one frame, source X, source Y, source width and source height, and the next four attributes determine where we want to place that crop image on the destination canvas, destination X, destination Y, destination width and destination height. So these values are reflected by player.x, player.y, player.width and player.height as we pass them to drawSprite function on line 31. DrawImage built-in canvas method with its 9 attributes is fundamental to understanding sprite animation with JavaScript. We covered it in even more detail in the previous episode and we will get back to it in the future. So now, if I want our character to turn right, on line 14 I just give frame Y value of 2 to animate the second row in sprite sheet, counting from 0. Value of 3 will make character facing up. So back down inside movePlayer function, I add additional statement. If keys 38 is true and player's Y position is more than 100, move player up and player frame Y is 3, which will give us animation row that displays our character walking up. If you managed to follow, well done. I will now repeat everything for left direction, left arrow key code is 37, and we want to say player X minus equals player speed. Move player to the left on the horizontal x-axis. We also need to make sure player can't walk past the left edge of the screen, so if keys array contains code 37, which is left arrow, and at the same time double ampersand, player.x is more than 0, only then enter the if statement and move player to the left. Also, player frame y is equal to 1, so walk in left animation from our Chewbacca sprite sheet. I do exactly the same for arrow down, key code 40, player x plus equals player speed, and player frame y is 0. And if keys 39 is equal to true, 39 is right arrow, player x plus equals player speed, and player frame is 2. So now we can walk in all 4 directions, and we are showing the correct row from our character sprite sheet. Of course, I forgot to set boundaries, so player cannot leave the canvas area. If keys 39 is true, and at the same time player x is less than canvas width minus player width, this will make it stop as soon as it hits the right edge of canvas. If key 40 is pressed, arrow down, and at the same time player y position is less than canvas height minus player height, again run the animation. Now we managed to set boundaries to the area within which the player can move for all 4 directions. You can see our player's legs don't move, we only skip rows, but we are not animating columns yet. The way most sprite sheets are organized, we need to change horizontal coordinates of cropping area to alter between frames to create walk-in animation. I create custom function called handlePlayerFrame. Inside, I put an if statement. If player.framex is less than 3, because our sprite sheet has 4 columns but we count from 0, player frame plus plus. If it's less than 3, add +1 for each animation step. Else, skip back to frame 0. Now I can go back on line 33 inside animate function, and I will call handlePlayerFrame custom function we have just created here. And we can see character walk-in animation is working, but we don't want it to be walking all the time, only when we move with arrow keys. So on line 16 inside player object, we created a property called moveIn, and we initially set it to false. One thing we can do is to go to line 38, and inside keyDown event listener, I set player moveIn to true, and inside keyUp, I set player moveIn to false. Back down on line 66, I add additional condition, only cycle through horizontal frames if player frame x is less than 3, and at the same time, player moveIn is true. Sorry for the typos, my room is dark, it's midnight here right now. Our character is moving way too fast. The simplest way to fix this is to lower the frame rate of our game using setInterval. It takes 2 attributes. First is a function to run, and the second is how often we want to run that function. I put 100 milliseconds, so 10 frames per second. You don't have to code along with me right now for a minute, I'm just showing you. So I take all our animation code, and instead of serving the next frame with request animation frame, which is the proper optimized way to do it, I will just run all our animation code inside setInterval. You can see we are controlling frame rate of our game, which might be necessary with pixel art games. It will run super fast on modern gaming PC, and we don't want that. But using setInterval is not optimal. Request animation frame synchronizes automatically with screen refresh rate, and it is generally recommended to use as a good practice. So how do we control how fast our game runs using request animation frame? I just delete setInterval and put everything as it was a minute ago. Now I move animate function to the bottom of our code, and I comment it out, just so we have it here for reference. I declare some custom variables. Let's call them, for example, FPS, FPS interval, start time, now, then, and elapsed. I just declare them here. I don't assign any values to them. I can do it as a comma-separated list. It will basically just set the name for the variables and declare their initial scope. So these will be global variables. I will show you how to write a function that will allow us to serve frames at a consistent frames per second rate that will be independent of how strong user's computer is, and it will run consistently across all machines. I create custom function, let's call it start animating. It takes one attribute called FPS. This function's job will be to kick off animation loop based on FPS we pass to it as an attribute when we call it. From the FPS variable that will be passed as an attribute, we calculate FPS interval in milliseconds. So FPS interval is 1000 because 1 second has 1000 milliseconds divided by frames per second. This will give us value in milliseconds, which determines how long we wait before we serve the next frame. We need to calculate how much time has passed from the last frame. So then equals to built-in Data.now JavaScript method. The Data.now is an inbuilt function in JavaScript which returns the number of milliseconds elapsed since January 1st, 1970. It basically returns a very long number. I will just call it twice and calculate the difference in milliseconds between the two to know how much time has elapsed. Start time is equal to then. We freeze that value for a while in this variable. Then I call animate, function we haven't declared yet. I create another custom function, I call it animate, I call request animation frame and I pass it animate, the name of its parent function. This will cause it to call itself recursively over and over. I also take now variable I declared on line 60 and I make it equal to Date.now. Elapsed will be a difference between now and then. If elapsed is more than FPS interval, then is equal to now minus elapsed modulus FPS interval. Modulus operator gives us the remainder obtained by dividing two numbers. For example, 5 modulus 2 is 1, because 4 is divisible by 2 and 1 is the remainder to get to 5. Modulus operator is important in JavaScript programming. We will get back to it in another video. What's happening here is I'm calculating how much time has elapsed between then and now. If the time that has elapsed is more than FPS interval, we reassign value of then to the current time and we run our animation code. I paste all our animation code here. Then the loop will repeat itself comparing then and now. When it reaches FPS interval, again it will enter the if statement, reassign value of then, and it will run all the drawing code of our game over and over. To get this to work, we need to call start animating function we declared on line 72. This function will take FPS we pass to it as attribute. It will calculate FPS interval in milliseconds, and it will kick off our animation loop by setting the initial then value equal to Date.now and calling custom animate function we declared on line 79. So I call start animating with 10 frames per second. (30 frames per second), 60 frames per second, 500 frames. Since we are using request animation frame, it will not overload our browser. It will max out at the maximum refresh rate of our screen. I can also do very low value like 5. You might notice that character sometimes kind of slides around and the legs don't move even though the character is moving. That is because the way we play games, let's say I'm walking to the right, I'm holding down the right arrow key. I want to change direction and walk to the left. Most people, like me, will first press the left arrow key and only after that release the right button. That way, the way I wrote the code, key-up event sets player moving to false, and since that call comes after I pressed the left arrow key, it will just stop animating for a while. The fastest way to fix that with this code structure is to add player moving equals to true to the if statement that check if specific key value is pressed in our keys array. So I just add it to all 4 if statements inside movePlayer function. Now the animation reacts with perfect precision. You can try the difference yourself if you're coding along. Well done, you managed to build a very solid basic skeleton for a pixel art game. Now, we can turn this into anything we want. Any creative ideas for game mechanics? Let me know in the comments. And show me what you build on CodePen, I always like to see other people's creative ideas. If you haven't seen it, in the first episode of my game development series we dive deep into sprite animation, and using ES6 classes we generate crowds of randomized NPCs. Also, check out my vanilla JavaScript and HTML canvas animation playlist for more fun with algorithms and the generative art projects. See you next time.